Thanks for joining us today for our Federal DevSecOps Virtual Summit demo. Today we're going to see kind of mini presentations for Rancher Federal, GitLab, Anchor, and StackRox. Hopefully by the end of the demo, you'll see how seamlessly all four of these products can work together to truly create the ultimate stack for DevSecOps within your agency. Up first, let's take a look at Rancher from Brandon Gulla.
My name is Brandon Gulla. I am the VP of Engineering here at Rancher Federal. Rancher Federal is a company designed to provide enterprise-grade Kubernetes and cloud-native support for the U.S. federal community around the Rancher Labs product suites. Everything to do with Kubernetes and cloud-native applications as a whole. So today I'm going to actually be showing off and demoing the Rancher Multi-Cluster Manager. Rancher is a great way of not only provisioning, but maintaining your enterprise Kubernetes clusters throughout your entire enterprise, whether that be on-prem, cloud-based, or even hybrid solutions. Rancher is the de facto standard of doing multi-cluster apps across the U.S. federal mission enterprise space in a highly secure and highly scalable fashion. So today I'm going to show you the Rancher Multi-Cluster Manager. This is the first view of how you can actually secure all your Kubernetes clusters throughout your enterprise. So if we wanted to add a new cluster, you can actually go in and see the different ways that we can add, whether that be provisioning new virtual machines on top of Amazon EC2, whether that be GovCloud, C2S, or SC2S, as well as other cloud providers such as Azure and Oracle Cloud Infrastructure. Additionally, if your stack, whether air-gapped or not, is running on a bare metal hypervisor, you can actually provision VMs natively using OpenStack or vSphere. So if we wanted to actually spin up a new Amazon EC2 cluster, we could actually go in and name the cluster here and provision exactly what we need. So we can actually utilize any GovCloud region or Amazon AWS region and use our own IAM credentials provided to us from Amazon. From there, you can actually set up your correct VPC, load your correct security group, whether that be a lockdown version or a manually provisioned Rancher nodes group that is set to be more permissive. From there, you can actually choose which sizing of nodes you want in a very usable friendly manner. Everything I'm showing you today is very point and click in a UI fashion, but know that you can drive all this through the command line or an API as well. So you can select exactly what size nodes your cluster demands. And from there, you can set certain features such as encrypting the EBS volume, the size of your root disk, or even the AMI. For those who aren't aware, the AMI is exactly the operating system used to bootstrap a cluster or an EC2 node. You can use our provided list of AMIs or select even your own AMI that's been pre-hardened for your infrastructure. From there, once you've gotten your clusters set up the way you want, you can actually define how you want your nodes to run, whether they're full-blown masters with worker built in or individual worker nodes, and you can scale them up appropriately. I'm not going to do this today since I've already created a test cluster, but know you can also dive in and do things like advanced options such as pod security policy, which is a great way of managing an initial security profile for your enterprise Kubernetes cluster. We also support Open Policy Agent Gatekeeper, which is a great way of defining that security down to a fine-grained level. Know that everything that we're doing here in setting for security is actually can be controlled at the multi-cluster level, allowing you to inherit all those security policies throughout your enterprise cluster. From there, we can go in and set up things like etcd snapshots. So for those who aren't aware, etcd is the data store within Kubernetes where all state is actually stored. You want that backed up. So natively, Rancher will automatically download those backups for you, but you also have the ability of doing S3 backups where you ship those backups off-site for further disaster recovery opportunities. So we can set an S3 bucket name, all of our IAM credentials, but know that for those in air-gap deployments, you can also utilize Minio, which is a great S3 compliant data store that will allow you to store these backups off-site. From there, you can actually set up exactly how often you want those backups to occur. And then other great automated features such as CIS benchmarking. Rancher has built in the ability to actually security scan your enterprise Kubernetes clusters for you and actually notify you when they fall out of compliance. So now that I've actually shown you how to stand up a Kubernetes cluster, know that there's additional ways where you can actually utilize existing VMs using the RKE tool, or you can import existing clusters. Say you already stood up a cluster using kubeadmin or OpenShift. You can actually import that existing cluster be managed by Rancher natively, allowing you to have two concurrent ways to monitor and configure your Kubernetes experience throughout your enterprise. You can also use a managed Kubernetes provider such as GKE, AKS, or EKS, and allow Rancher to manage those as well. So now that I've showed you how to deploy a new Rancher cluster, I'm actually going to show you how you can deploy apps and maintain those apps over time with day two operations. So right now we're looking at a new screen that will actually show you the cluster view of what's going on within your cluster. You can see things like utilizations of CPU, memory, pods. You can actually see temporal graphs of what's happening over time. If that's not enough of a view for you, you can actually click on any screen that you see that little icon, the Grafana icon, and see a full-blown view of what's going on within your node or your cluster, whether that be CPU utilization all the way down to host traffic on a node showing ingress and egress rates for packets going in and out of those network interfaces. Back at the Rancher view, we can see a little bit more about the cluster. This is a demo cluster that we're using here for the StackRox demo, and we can actually go in and see what's happening with each pod and each namespace at any given time. So here we can see the different pods that are running, the daemon sets. We can drill into either or any of these pods, which are collections of Docker containers, and actually troubleshoot in real time. So here we can see that we're running the Grafana image and the Grafana proxy image as well, based on Alpine, and we can actually dig in and see exactly what's going on. With Rancher, you no longer have to SSH into every node and cat your log files to see what's going on. You can actually do a real-time view of exactly what the standard out logs from each container are running in a great view that's completely SSL bound, and you can integrate with PKI authentication as well. From there, you can actually troubleshoot with a live HTML5 shell. So from here, you can actually perform any operation that you would be able to do over SSH, but in a fully HTML5 shell. From there, we can actually exit out of this and see more about the running metrics through those same screens that we mentioned earlier, as well as events and statuses that happen all the time. You can then go in and actually see the node scheduling, where the pod was actually scheduled to run, and some of the rules needed to run that operation. If we wanted to run our own application, let's hop back over to the default namespace. If we wanted to install our own application, such as a GitLab or StackRox, you can go to this screen and click launch, and you can see our full app store, if you will, or catalog store of what you can install within your application. You can actually add your own Helm charts here. This catalog is using Helm, and you can use your own catalogs. So here we're using the upstream Helm charts as well as the Rancher charts, but you can add your own enterprises as well, allowing you a point and click interface to launch applications on top of your Rancher cluster. So from here we can install things like CockroachDB and have a full-fledged web experience to actually install these with these. So for example, we installed Longhorn earlier, and we can click on Longhorn and see Longhorn, which is a great cloud native way of installing block storage devices for your Kubernetes and Docker applications. Back to our Rancher cluster, we can see a little bit more with what's going on with our cluster. If we go here and say launch kubectl, again, you get a full-blown HTML5 Unix browser or Unix shell, where you can say get nodes, wide, and you can actually see what's going on within your cluster and manage it as if you were running an SSH shell on your local box. From there, you can do other operations such as etcd snapshotting, CIS benchmark scanning. So we can go here and say scan, and we'll actually look at those results here in a minute. And then we can also view an API Anywhere that you see this three dot drop down within Rancher, you can actually view an API and then get the full API experience where rather than looking up your documentation over and over again, you can show any request and it'll actually show you the full curl command and HTTP header or body that you need to submit to perform that same action, allowing you to integrate this within your GitOps strategy and workflow. So this is a great way of enabling your developers and your operators to be able to manage your Kubernetes clusters automatically or dynamically through a GitOps solution. All right. Backing up to Rancher, we can go back to our CIS benchmark scanning that we performed earlier, and we can see that we passed. And you can actually go and see exactly which of the security controls were tested and how you performed on each one of those nodes. You can dynamically set up alerts where if your cluster falls out of compliance, it can notify your network operations command or even your management to let you know that there needs to be day 2 operations performed to ensure compliancy. That being said, this is Rancher. I hope this was a great introduction for you. If you have any questions, be sure to reach out and we'll be able to help you along with your cloud native journey. Thanks so much.
Now let's hear from Joe McCairns from GitLab.
Well, thank you for that. So as we talked about earlier, GitLab is a end-to-end DevSecOps product, starting from on the far left side, so to say, with requirements gathering, all the way to the right with a defend column where we secure the operational environment. And certainly throughout the process, it's all about security as we're talking here today. So to begin with, I see that I have a new issue that's been assigned to me. So I'm going to go head over to the issue board and take a look and see what's going on there. Now, this is our user stories, if you will. This is where people can go and put in that they want enhancements done, or there's a bug in the software, or a vulnerability. So in this case, we do see that somebody apparently tried to deploy a Docker file, and we recognize that there's some vulnerabilities. Looks like some unauthorized ports. A user is in his root, things like that. So we definitely want to go fix that. Now, the other way we can see is if we were to go to the merge requests. This is where apparently somebody was working on the file, went in and tried to make some changes and tried to submit it. And we see that certainly to begin with, GitLab built the files. It ran some tests. There were some warnings, and then it failed because obviously we've got some vulnerabilities that we want to stop and look at. So one of the things about GitLab is that we move all of the security scanning very, very early on in the process. We want to be as near to the developers when we do any type of security scans because the developers are still working on the code. Everything's in context of the code. More importantly is the fact that right here when they committed this branch of code back to master, they made some changes, I guess in the Dockerfile perhaps, submitted it back to the master, these scans ran. Now we do a number of security scans, or can do a number of security scans, starting with code quality. We'll look for the structure, we'll look for any hidden or embedded secrets that shouldn't be in there, bad programming practices, if you will. From there, we do SAST, or static application security testing. We can do dynamic application security testing, or DAST. We can do container scanning. We can do dependency scanning. And then lastly, we can do license management. So many times our projects are using open source licensed software modules. As you may or may not be aware, but in the Department of Defense, a lot of those modules are on the do not use list, if you will. But the beauty of GitLab is it not only embeds all those security scans, we also embed external scans. So if you're using Anchor, for instance, those results can actually show up in this merge request. So at this point, perhaps I'm an approver or I'm the team lead. Somebody did this merge. I'm getting alerted to it because, again, I've got my alerts up here in the top right. And I see that, yeah, for sure, we've detected new vulnerabilities. Now, this is certainly just a demo, so shouldn't have 79 vulnerabilities, but we'll go with that. And I get the list of those vulnerabilities right in this merge request. So it's actionable data. It's at my fingertips. I see highs, mediums, lows, criticals, etc. But more importantly, when I open up one of these security scan reports or CSVs, what I actually see is what happened, why it happened, and actually who did the scan to report this back to me. So this is actionable data. Again, I'm right next to the developers. They just committed this code back. I'm getting this information, and it's actionable. So if I'm team lead, security person, what have you, and then I can act on this. I could perhaps just dismiss it. Probably not a critical one, but if this is some kind of vulnerability, or you know what, it's staying inside, it's an air-gapped environment, I just want to get this code deployed to try it out, type of thing. Totally up to you, but that is an action you can take. Or more importantly, with GitLab being extremely highly iterative, we could turn around and right from here create an issue that's going to take all this data, open up a new issue as we looked at a few minutes ago, create the issue, put it in that issue board, and it can get assigned to somebody to start working it right away. And that issue could be based on a template even. So if I have certain layout I want to use, things of that nature. So here we see, okay, Anchor did run this scan, it failed. Let's go take a look and see what's going on. I'm going to go back to the repository for a minute. And let's take a look at this Docker file, because I know we want to definitely get this out the door and running. So if I look through here, everything looks good so far. Could probably do a search if this file were any bigger. But here, sure enough, we're exposing port 80, which is not good, and it's running as root. So we don't want to do that. So I'm going to just go ahead and edit that. We're going to take those couple lines out. Now, again, I could, go through the process, create a merge request, create a branch of this, so my changes are being tracked. I am actually playing around in master, which is usually not something you want to do as in good developer terms, but just for purpose of demonstration, we're going to go ahead and not worry about creating a whole new merge request, etc. I'm going to go ahead and commit those changes. And now if I were to come back to the pipelines, as you know, we run CI/CD pipelines, and these pipelines automate a lot of the manual tasks we would normally do. And here we see, for instance, that we've got 3 stages: a build, a test, and a deploy. So we're going to rebuild the code. We're then going to run a number of different scans on it. Of course, you see that we've integrated to Anchor, so we run the Anchor scans on this. We can check the merge request when a pipeline's done, make sure there's no vulnerabilities. But in this case, it would have stopped anyway if there were. And then it's going to go ahead and deploy that out to the production environment. So just a quick day in the life, if you will, of GitLab, but having a centralized repository for the versioning control, having the issue boards where I can go in and manage the issues and work on them. In this case, I want to move this over to doing, because we are in progress working on it. And all the information highly collaborative, so we can see that non-developers or all my constituents that are concerned about this or have input to this can actually work in here and collaborate together. And then we can go ahead and when we're all finished, we will just move that over to closed, and we're done our work, and we can start on the next project. So with that, I'd like to pass it over to Anchor and let them go ahead and talk more about their great product.
Thanks, Joe, for cleaning up that image and changing those things in that Docker file and showing us that demonstration about GitLab. My name is Hayden Smith. I'm a senior engineer in field services with Anchor. Today, we're going to be looking at the contents of that image that Joe was working with. We're going to be exploring the vulnerabilities associated with that image. And very importantly, we're going to be looking at the compliance baseline that was applied to that image. So let's take a look and see what showed up in Anchor when Joe was pushing those images through the pipeline. So the first one generated a stop action. This is the image Joe was working with that had Metasploit and Nmap installed. We can validate that by going to the Contents tab. This is part of Anchor's deep image inspection, which decomposes the image layer by layer. This gives you all the dependencies and packages and files that are listed on the system. You'll see here we also list the license associated with each package. So we do a very deep inspection of that image. Let's see if we can pick up Nmap and Metasploit and just query those quickly off the bat to see what we can pick up. So first, Nmap, yep, that's on there. We see the license attached to it. Metasploit, yeah, that's also on there. Those are two packages that should be on a basic Nginx container. We could also go to the changelog and see when those were added. So we could see we have it filtered on 25 added, and we can actually query here to actually see that it was added. Yep, that was added in from the original Nginx file. Let's go and check out the vulnerabilities associated with it. So you'll see here, there's nothing really crazy about this image in terms of vulnerabilities. 1 high, 7 medium, 2 low, and 82 negligible. That's really not too bad for a container image. Anchor provides the ability for you to filter based on CVEs that have fixes available. So let's do that. So we have one CVE with these fixes available. Again, nothing really eye-popping here, right? But I like to say there's things that you can do in this space that don't have a CVE attached to it. For example, using root user, as we saw Joe had to fix in the previous part of the demo, that has no CVE attached to it. Exposing those ports has no CVE attached to it. Grabbing Metasploit and Nmap down has no CVE attached to it. But those are things we monitor for in our compliance. So you see right off the bat, we have already blacklisted Nmap and Metasploit. We know those aren't supposed to be a part of that Nginx base image there. We see those ports exposed, 21 and 22 for Telnet and SSH. Again, not supposed to be there. And then we see things like private keys and secrets being picked up in Anchor right here. And then let's filter this a little bit, see if we could find that root user. And again, we see that root user listed here. See what the warn actions are, take out that root query. And again, we're getting another warning to let us know those ports are exposed. And these are all being generated via the Anchor DoD security policies. These are policies we've spent developing over the past year with Platform One and the team at the United States Air Force. So let's actually explore that policy a little bit. So when you go to the Policy Bundles tab and you see this Anchor DoD Iron Bank security policies here, you'll actually see a ton of different vendor-specific checks that are mapped out for each. I like to say that these take information security best practice, such as establishing the proper user for that application and only exposing the ports that are necessary for that application to run, and applying those to each specific container. So for the Nginx container, we had very specific rules mapped out. User had to be this user, not root. And then we have these ports declared on the Nginx whitelist. So if you pop back to the image very quickly, you can actually see in compliance that we map those Nginx checks specifically to Nginx. And you'll see these Dockerfile checks generated from our policy, in addition to file checks, software checks, transfer protocol checks. Those are all basic checks that we will explore here in just a second. And we could see how deep Anchor can go with policy inspection. And then we see the whitelist applied. So these are basic files that are associated with this Debian image that we went ahead and whitelisted. So that way our security teams know not to waste their time worrying about those things. So again, we'll go back, we'll hit edit, we'll explore these checks a little bit more. So you can see the Dockerfile checks listed here. These are really great because you have the ability to go in and select Dockerfile as the gate, select instruction, and you have the ability to add a specific check for anything that your developers may pass in a Dockerfile. And you'll see all the different Dockerfile commands here. So you'll see things like run. So if you wanted to monitor for that Metasploit pull down, you could actually just do run exists and then pass the regex expression for curl here to go monitor for that curl command that was pulling down that Metasploit package, and then select stop. You could also go here and add edit. You could then go into these software checks. You can monitor for secret scans. You can monitor for certain things associated with the vulnerabilities of that software. You could go into user checks. User checks, we go ahead and, that's the Istio policy. User checks, we go ahead and monitor and blacklist for root and Docker. And then we have transfer protocol checks. So again, we're checking for things that are going out and calling SFTP, HTTP, HTTPS, FTP, and these specific Docker commands. So again, that was generated using the Dockerfile gate, going in, selecting instruction, and then selecting for that specific command. It was from, and then this, and then that HTTP sequence. And then one thing I just wanted to show you guys is how you would actually blacklist that Metasploit package like we did here. So we're going to pop back down into the software checks, go to packages, go ahead and blacklist, and then you would just specify the name and version of whatever package you wanted to blacklist from that contents tab that we saw earlier, right here. And if you want to blacklist the package outright, like we did with Nmap and Metasploit, you don't even need to specify the version. You could just drop the version, specify the package, save and close, and these will immediately be applied to your images. So it's not just doing those 2 checks for each of these specific vendors. We layer on top of that industry best practice checks and DoD best practice when it comes to transfer protocol, appropriate users, appropriate software checks, appropriate file checks to make sure you're not adding in anything malicious. And if we wanted to actually generate a report about anything we saw here today, as of Anchor 2.3.0, we have the ability to automatically generate reports. So going to the reports tab, I went ahead and generated a report that will just give me critical vulnerabilities against all my images. So let's dive in here. You'll see all the critical vulnerabilities here attached to the appropriate image, and it will tell you when the tag was detected, if the tag is current or not, and the repo that's affected. Going back, I like to focus on things that my developers and security team can actually fix and burn down, because I think that's the appropriate way to manage software, right? You want to keep everything as up to date as possible. So I went ahead and generated a report that simply gives me all the fixes for all the vulnerabilities that have fixes available against all my container workloads. So I could go here and I see the vulnerability ID, I see the image and repo that's affected, the artifact for the patch that needs to be applied. So this will give my team everything they need to go ahead and start patching my system and start remediating some of those vulnerabilities. So that way you have a lot cleaner scans coming back in the future. And then we actually have another report that you could use just to see which containers are meeting DoD compliance. So if we go there, we have DoD policy failures. We could click here on view, and this will spit out a list of everything, every image that is not meeting the DoD compliance standard daily. So if you were to go back, you could see that this report kicks off nightly at 8 p.m. So every night I have a report that's generated for me automatically via Anchor that can go ahead and notify me about all the images that aren't meeting compliance. And then let's just go back and make sure Joe cleaned up that image. So if you see here, this is our latest tag. You'll see that everything has been passed. You'll see we actually got rid of one of those high vulnerabilities that must have been associated with Nmap or Metasploit. And let's just make sure that nothing is showing up anymore. So Nmap is no longer there. Metasploit is no longer there. And a lot of those compliance issues are no longer there. So that root user, that port 21, port 22, None of those are apparent now. So it looks like we have a clean image. So we went ahead and generated a pass action. That is a great demonstration about how we can incorporate Anchor with GitLab in your software delivery lifecycle. Now I'm going to pass it off to Andy and StackRox, and he's going to talk about some of the threats and security issues that can happen once this container goes on and hits a Kubernetes workload and is run in a Kubernetes environment during runtime. Thank you.
Thanks, Hayden. I'd like to introduce myself first. My name is Andy Klemenko. I'm a senior solutions engineer at StackRox. Now I get to show you how we can actually monitor all these deployments once you've actually got your image through the pipelines and approved by Anchor's policies. So what we're looking at right now is our dashboard. Let's take a look real quick in terms of what we've actually deployed. Okay, so I've gone ahead and deployed the image that was shown in earlier demos. And I've got 4 replicas actually deployed right now. And you can see it's coming from registry.stackrocks.live, demo master, demo nginx master. Okay. What I'm going to do is I'm going to flip over to the violations first. Okay. And we see that we've got curl, we've got latest, and these are based on our policies within our platform. And the policies can apply to runtime, can apply to the deploy phase. What I'm going to do is I'm going to have a little fun here. I'm going to be a little mischievous. So I'm going to pick one of these pods and I'm going to exec into it. Good old bash. And what I'm going to do is I'm going to do an apt update. And then what I'm going to do is I'm going to do an apt install Nmap. The worst program known to man, right? Nmap's a pretty gnarly one because it definitely allows an opportunity for an attacker to kind of do nefarious things. Okay. And notice we didn't get an additional Ubuntu package manager execution. We already had one up. We don't believe in constantly spamming. And it was within the same namespace. But what we're going to do now to make this even more fun is we're going to run Nmap. Now, I'm going to run it in a safe mode, right? I'm going to just do a help. And let's go ahead and run that. And what we'll see is relatively quickly, we'll see an alert pop up for Nmap execution. Okay, now we've currently got enforcement turned off. With enforcement on, it would actually kill the pod, and the pod wouldn't actually get recreated based upon how Kubernetes works. But here's where it gets interesting, right? So we've got the violation. We can actually drill into the violation. I can go ahead and create a note. This is a demo. I would also recommend linking it to a ticket system here, and that would allow you to kind of cross-reference findings within our platform as well as other events, other systems. So we'll go ahead and save that. But what we can also do is kind of look at this from a different point of view. We can look at it in terms of risk. So our risk tab looks at all of the deployments and rates the risk on a lot of different factors. So what we can do right now is let's go ahead and look at the namespace nginx 3 production. Okay. And it's number 19 on the priority list. So again, we're going to rate the risk based on a couple different things. Policy violations is first one. Suspicious process executions, right? Detected execution of suspicious Nmap with args -- help. We can list the vulnerabilities because we're actually able to pull the image vulnerability list from Anchor. We do have an integration with Anchor that works really well. So we're actually using their scanner to pull these numbers of CVEs. Port reachability, service reachability. We've also got components useful for attackers. Is apt in there as our package manager, as our curls, GCC, things like that. These are kind of important. But here's where it gets really interesting, right? We can go and look at the process discovery, and we've effectively whitelisted that process and said, okay, this is normally what runs on this Nginx container. A bunch of standard stuff, entry points, things like that. But notice in red Nmap, that stands out. So we detected that both as a policy violation, but also as an anomaly. Here's where the secret sauce comes in. We can go ahead and view the graph. And this graph is going to show all of the pods within this deployment and all of the events leading up to those violations. So what we'll do is we'll actually zoom in here. I'm going to zoom in, and we're going to look at just at these violations. and we've got our Nmap. So we can actually go and see, okay, pod v9 s2s had a violation at 9:52. We've also had another policy violation, package manager, because guess what? I was testing that before I recorded it. So this is really good vital information for incident recreation. But here's where it gets fun. So we can actually export this as a CSV file. So we can use this as effectively the history of everything that happened to this deployment, not just pod. So imagine you've got a very large scale application. You want to see, hey, did an attacker get into one and jump to another? It would actually be identifiable here. So I think this really kind of takes the runtime capability of our platform and really supplements not only the build time capability with version control, with GitLab, with Anchor, but we can take it even a step further. We can also start looking at compliance. And compliance for us really means, I'm going to run another scan. Compliance for us really means compliance of the infrastructure. So here we've got a Rancher cluster, but also Kubernetes, also some of the applications as well. So let's take, for example, NIST 800-190. Okay. Image vulnerability, say control 4.1.1. Image vulnerability organization should use tools to take the pipeline-based build approach. Well, guess what? We passed that because we have the pipelines coming off of GitLab and Anchor. We've got those pipelines. We've got the image vulnerability scanning and compliance piece of that. But here's where I think our platform kind of excels is we have the ability to export the report, export the compliance report, download evidence as CSV. One of the things that I find absolutely awesome about this is not only can you download it as a PDF and CSV, but you can even use our API reference and automate this. This is one of the major hurdles to really think about continuous ATO. This idea of being able to ask the cluster, what is its current compliance number, and then ask it again in a week or 2 weeks. And now you get to start to see a delta. And that delta will help indicate, is your cluster getting safer or is it getting riskier based upon violations and based upon the policies built into our platform. One other thing I'd also like to show you that I think our platform excels really well in is this idea of a network graph. So this comes from the fact that our platform is Kubernetes native. In other words, we need Kubernetes to deploy, but we can inspect any and all things Kubernetes, all the objects, all the namespaces, right? One of the things that we do really well is we actually start to baseline our what we see, the metadata. In this case, we're baselining the metadata for the network traffic. We did the same thing baselining the binary execution within the pods themselves. And what we can see is this is all the active communication over the last hour. We can go look at what's allowed. Now here's where the real sauce comes in, right? The fact that one of the major things in security is trying to reduce surface area for an attacker. This is a great way to do it because we actually have a network policy simulator and we can generate Kubernetes native network policies. What this basically allows us to do is to take that baseline and make a very strong suggestion about how to prevent container A, pod A, from talking to pod B. This can be across namespaces. This can be within the same namespace, right? We can use Kubernetes primitives to dramatically reduce the surface area of your network. In this case, your virtual network, SDN, so to speak, within Kubernetes. One of the other great things about this policy simulator is we would absolutely download this or upload a new YAML, but I would highly recommend downloading it into a different repo within GitLab and really kind of leveraging that infrastructure as code. And I think this is where we kind of can bring a lot of these things together because not only can we do the network graph as infrastructure as code, we can also then go into our system policies and we can import and export them as well as infrastructure as code. So now you can actually be more declarative in your StackRox deployment, in your policies, as well as the network graph, the network pod policy recommendations, and effectively kind of bring all this together and take advantage of a strong runtime observability, and actionable intel. I hope this helps kind of sell everyone on this entire stack of GitLab, Rancher, Anchor, and StackRox. I think having a succinct solution like this really kind of takes some of the guesswork out of building it yourself. And hopefully you enjoyed this demo. Thanks for watching.